All right, solving exponential and logarithmic equations. Now, this is probably some of the stuff we're going to need when we do these financial problems that we're going to talk about, and the crescent little kind of stuff. But, you know, we don't always go into the background of Mr. Creswell and I, but can you find Mr. Creswell? It's like, where's Waldo, the doof with the hat on? And there's his brother right there. Look at that. What yeah.
Oh, wow. Putting it all together.
Yep. Notice I'm not even up there yet. You guys were all celebrating. I wasn't even there. But Mr. Creswell is one of my state champions. So, state champion logarithm solver as well. All right, go for it there, senor.
Okay, so I've got to find a way to get this x out of the exponent. So I'm trying to solve this stupid thing for x. And I think one way I can do it is take the log of both sides. I think that if I take the log of the left side and the log of the right side, just like any equation, when I do one side, I got to do the other.
It's bothering me. Is that okay?
Yeah, that's fine. Yeah. Log of 28. And then what happens to this x there? Where does it go when that happens?
Well, you could bring this x out in front.
Okay.
All right, you can bring that was one property you taught us.
Yeah.
You can bring the x out in front, and that's why you do this. This log, anytime there's an x in the exponent, I take the log of both sides.
Okay. Cool. So the x comes out in front here, and then it's gone from the top, and then I can divide both sides by log of 5, because remember, log of 5 is just a number. Divide by log 5. And then I'm left with x equals this mess, which I think...
Log 28 divided by log 5, is that what you'd like me to do?
Yeah, let's do that
log
in the
28 divided by log 5. So we'll go log 28 divided by log 5. Oh, you know what?
You forgot your parentheses.
Son of a bee sting. Okay, here's what we're going to do. Log 28, finish the parenthesis, divided by log 5. Shame on me. At least we caught it. So 2.07. I don't think I would have gotten 2.07 by doing guess and check. 5 raised to the 2.07. Well, we knew it was about 5 squared because 5 squared is 25. So the 2 sounds reasonable. But all right, so let's crank it up just a little bit here. Oh my. Oh my. And let's add some more guck in there before we get going. I've got 3 times this ugly thing equals 81. Now, I would personally get the 3 out of there first because I don't know what to do with that. So it's being multiplied by the 4 raised to the x over 3. So I'm going to divide that by 3. Oh, I got a fat pen. Did you see that?
That's
fat with a PH. What's 81 divided by 3? 27?
27.
Okay. Well, that's cool. I think my pen's just a little too fat. Now, I've still got this x up here is in the exponent. And I want that out of there. Even though it's attached to the 3, I want to get that out of there. So let's take the log of both sides. Now, we could have taken the natural log of both sides, couldn't we? It really wouldn't have mattered. Now, this whole parenthesis gets moved out front. Well, that's exciting. So we have... Oh boy, we're gonna run out of room with the calculator, aren't we? So x over 3 is up front times the log of 4 equals the log of 27. I want to get x by itself, so I want everything else to be moved away from x. Well, why don't we move this ugly thing first? How do we move that?
Divide by.
Divide by log 4. Well, this is looking really bad, isn't it? So now we have x over 3 equals, we need a number for this. Log 27 divided by log 4, right? So whatever that is, log 27 divided by log 4. We're going to put that in the calculator in a minute. Log 27 divided. How do I get this 3 out of there?
If I'm dividing by 3, I think to undo that, I've got to multiply both sides.
Yeah, the opposite of divide is multiply. Yep, I like that. So just so that we can see, we'll multiply by 3. We'll multiply by 3. Those are gone. So it looks like log 27 divided by log 4 times 3. Can you remember that? Log 27 divided by log 4 times 3. Log 27 divided by log 4 is then times 3. Was that it?
Yep.
Times 3. 7 point whatever. And again, I wouldn't have got that on guess and check. So, are we good?
I think so.
You can always pause, rewind, watch it again.
Yeah.
I think there's great value in that.
Absolutely.
Pause, rewind. So X was 7.13, something like that. Is that what we're looking?
Yep.
Oh my.
Oh.
So X is approximately 7.13. You like my approximately in there? Little squigglies. A lot of times kids don't see that before. Sorry, you aren't kids. I apologize. Sorry. Unless you're having your little brother or sister watch us, which would be really kind of weird.
Okay. So I've got the log, and now X is in the base. Before we've dealt with it where it was up in the exponent. But I think that my same rules are still going to apply. I think isn't this a base 10 here?
Yeah. Assume
So-
if it doesn't have
Yeah,
the
if it's
10
not
number,
written,
assume it's a base.
we assume it's a base 10. And I think that if I took 10 as the base and put each side as an exponent in the 10, I think that'll cancel out my log on the left. So when all kind of...
I don't think. I know it will. Sorry. It will.
It will. I'll have x cubed and 10 raised to the second power, okay, which is just 100. And how do I get rid of a cube? Well, I think that I can take the cube root of both sides.
Man, you got a lot of stuff going on that screen, man. Okay, go ahead.
Okay, x equals the cube root of 100.
Is that a good answer? Can you leave it like that?
I'm okay.
I'm okay with
Yeah.
that too. A
Yeah.
cube root of 100.
Yeah.
I think that's a very good answer. If not, punch in your